Hi, Jim Berthel here again, with the third in our series of getting to know how to use OLI Flowsheet. We're going to continue with our neutralization study, and you can see that I have my File Explorer window open here, and all you have to do to open a case again is to double-click it. So we finished up the previous video with neutral 2B, and here we're just going to go ahead and double click it. Right. And that was that easy. And you can see we have some details from the previous case stored in the output window. What we're going to do here is we're going to add a recycle stream to this. Essentially, we're going to introduce additional mass to the model, and then we're going to purge part of that stream and recycle it upstream. So we have a few steps here, so we'll just go ahead and get started. The next stream we're going to do is just go ahead and add a mixer stream. We'll connect the outlet to it, and we're going to create a new stream to it. I'll press the escape key here, which will turn it, switch it from stream mode into input mode. I'm going to rename this stream called Salt Addition. It will be at 25 degrees, 1 atmosphere, and we're going to add in solid sodium chloride. Now you notice that there's no sodium chloride present in the inflow list. We can quickly add it. We'll just go back to the chemistry model. Go ahead and type it in. Go back to Flowsheet, and you can see it automatically added it to the stream. It should be important to note that it didn't change any previous results doing that. I'm going to add 75 moles to it. Now I'm going to tell the program that this is a solid only stream. That's under set phase, and it will be solid only. The program will only calculate the mass of the stream and its total solid enthalpy. It will do no other equilibrium calculation. I will then take the outlet of the stream. This stream is just an internal stream, so we don't need to rename it. I'm going to introduce now a split flow splitter, and I'm going to connect the stream to it. You can line things up a little bit, and there will be two outlets. I'm going to give them a lot of distance. I'm going to, again, press the escape key to get it out of stream mode. This stream here, I'm just going to call purge. And this one will be called recycle. Double click again. Let's put a nice capitalization in there. Now the split block needs to be told how to split. So we're going to go ahead and enter the block, and we're going to give it some parameters. We're going to actually be rather conservative here and say that 75% of the material will be purged through the purge stream, and 25% will be sent to the recycle. We've also done that in mass and in volume, but we're just going to base it upon moles here. And then I'm going to go ahead and try to make this all fit on the same screen. To do that, I can click this little center button called Zoom to Fit. And I get a little bit more room. I can then take this recycle stream, and what I want to do with it is I want to bring it all the way around. Now, I don't personally like the way this looks, so I will drag things around to make it look a little cleaner. And once again, I will zoom to fit. Okay. Now, even though I've called the stream recycle, it is not yet a recycle stream. I need to tell the program one of these streams has to be torn, or the phrase is selecting a tear stream. I'm going to pick the obvious one here, and now this is a right-click option, okay, called Set Tear Stream. And it puts that in, the little tear stream icon there. There was another way of doing it. I could have gone into this program option called Recycles, and I could have selected my tear streams. And here we get a graphic representation of the tear streams, your choices. Now I could have picked any one of these tear streams. As you can see, the double hash mark moves around. In principle, I picked the tear stream that has either the most information known about it or the least information known about it. And I don't know that much about this tear stream, so I'm going to pick it. It does require a guess, and you see that now that I've clicked it, I have a blank set of inputs. Now, for this particular case, this might be all right, but let's give it some values. Okay, and maybe it's mostly water, so we'll just start with water. Now would be a good time to save the case. Now I will save it as a new name. File, save as. Neutral 3. I want to just point out, let's take a look at the caustic value here, that it put in 277 moles of caustic into the stream in the previous run, and I will now run it. I also have what's called a convergence monitor here. This is actually going to trace the tear stream. Now, this is a very simple process, but it started off with a really bad guess and is moving towards this green line here, which has a value of 1. It looks a little lopsided here in the screen because it's so small, but I can make it a little bigger. So it's going to get to the point where it hits this value of 0. It's actually 1, and it's going to just say, I'm converged. I can now look at my recycle stream, and I can look at the calculated variables, and you can see that I have a lot more composition here than I had in my original guess. The controller, if you would notice, the amount of caustic being added was 277, is actually a little bit less now. Now, let's say I make a change to the process, it's going to start all over. So I can do 2 things here that will help the program run much faster. The first thing is called the restart options. And I have a recycle stream. I can update its value. So now the recycle definition is updated from the guess. Okay, we're back there. And we'll go ahead and rerun this. We'll go look at the trace here. You see conversion 5 iterations. When I run it, it basically ran at 2 iterations. So let's change the split fraction here, and let's make them even. And we'll just, once again, rerun it. Very, very fast calculations. So that was just an example of how to set up a recycle stream in OLI Flowsheet. And all the other things that we've discussed with the process simulator are still true. Thank you for your attention. Oh yes, and save and save and save.